is a filter separator. Here's what we're going to see, I think. Okay, everybody see that okay?
Yeah.
Good. Okay. Vertical, we're standing up. Two-stage, because we have a coalescer on the left and a separator cartridge on the right. Everybody see that?
Yeah.
Okay, so first of all, we're going to flow inside out through our coalescer. Coalescers, here's a couple of good examples here. We'll pass these around. You'll notice that you have pleated media on the inside, and that takes care of the dirt particles or contaminants that are in the fluid, and the outer wraps of fiberglass are going to squeeze the water out so it drops to the bottom to the sump so that we can drain them. Now, the coalescer, by API rules, must be 0.3 micron. 0.3 micron.
That's where I read that.
That's by API qualifications. Now, in industrial applications, it could be 0.3, 0.5, 1, 2, 5, 10, 25 micron, depending upon the product that they're running through the filter at that time, or what product stream, whether it's in a refinery, whether it's in a pipeline, or whether it's at the airport. Okay, any questions on that? Now,
how efficient is it supposed to be? 0.3 micron to 3 micron?
About 99%.
About that?
About.
So very efficient.
Okay, now, second stage, our separator, we are flowing outside in. And in jet fuel and aviation gas, we use a Teflon separator. Teflon is a coating that's applied to the screen, and that is hydrophobic, meaning that it collects water until the water droplets become heavy and join together, and then they'll drop to the bottom, so that any moisture, any water that is collected can be taken out through our drain. Now, part of the API is, the final part of it is, we're flowing in the vessel you'll see this morning, 500 gallons a minute, and the final test is 3% water. So how many gallons of water is that we are removing from the fuel per minute? 15 gallons a minute. So when you look inside of the vessel, it looks like it's raining. And the sump with our drain, in our case we used a manual drain, was like turning the hose on full blast. Because out of your 500 gallons per minute fuel flow, you are injecting 3% water, 15 gallons per minute. Okay?
That's a lot of water.
That's a lot of water. In Brazil, we've actually seen at the beginning of the process in diesel fuel as high as 5 or 6% water. So what you'll see throughout the world, in your area, you may see 1% water in new product. You may see 5, 6% water, depending upon the fuel. And what we'll see later this morning, the further we get from the refinery and closer to the airport, the fuel has been cleaned 10, maybe 12 times. So you're dealing with a much cleaner fuel. Okay, any questions on the two-stage? Now, on the two-stage, you'll see that we have a differential pressure gauge. This is a piston type. We can also use a differential pressure gauge. We can have a water slug control valve. If we get a large slug of water, we'll get rid of it. We can have an auto or a manual drain. Up on top, we have a pressure relief valve. In some applications in the pipelines, they may be filling the vessel after a filter change. Instead of filling the vessel gradually, somebody who hasn't been trained well might open that valve wide open and bam, here comes this surge of fuel. You have all of the air within the vessel, and that allows the air to vent rather than pieces of the filter housing flying through the air. So that relieves the pressure within the vessel. We also have on top pressure relief, and we have an air eliminator that if we are filling the vessel properly, bringing the vessel up slowly, that the air can escape automatically rather than a manual air drain, someone holding the valve down, and that will let the air out. Then once we squirt fuel, it automatically shuts off because we know that the vessel has been evacuated of air and we're now full of fuel. Now, within the vessel, you'll notice how the elements are setting. And we're going to see a couple different examples this morning. We will see a standard stool. All vessels have a threaded rod. And then here is a stool that has a knife edge seal for the element to set on. So our element gasket is going to set here. One of the other examples we'll see this morning, instead of having a knife edge seal, we will have a thread base so that the element has a large threaded space end cap on it that screws onto that. So we're going to see two types. Now on the top, you can see a single open end. In that case, it will have a threaded piece here that we'll put our spiders on, and then we'll torque a nut. On others, this will be an open-ended with a seal. And then again, we will have a spider on top with a knife edge seal. So on the bottom, we can have a stool, we can have a thread base, and you'll notice after our part numbers, if it says TB, that means it's a thread base. If it doesn't say that, you can assume that it's a double open-ended cartridge. So we're going to see both styles this morning.
Which one is going to give a more positive sealing?
I'm sorry?
Which will give a more positive sealing?
Right here.
Not the thread.
The reason they like these are on some of our longer elements. If you're dropping a 56-inch element into a vessel, you might not get your gasket directly on the knife edge. So maybe it'll slide over a little bit. So on some of the longer elements, they like to go to a thread base rather than a double open end. I'm sorry? Horizontal also. But we're going to see a vertical today.
Yeah, but I think the reason why sometimes they like thread base is when you have a horizontal
Yes.
installation.
If we have a horizontal vessel, then here's our, like so. Then the element will sit here, and then we know that we have a positive seal. Okay?
It's horizontal, it's more positive to screw it in.
Yes, so you can get to it. Okay, everybody with us?
No, I think I've got some bits missing here.
Yeah.
What are you missing?
Both pages.
Those
Three-
two sheets,
three
okay,
leaflets.
we will get those for you when we come back.
Okay, thank you.
Okay, one other thing we will see today. One of the trends here is to a green element. We talked about that yesterday. And we have what's called an HIF coreless. meaning it has no metal center tube. So it can be crushed. All of our end caps are glass-filled nylon, so it can be crushed or it can be incinerated. Okay, so what we do is that we have a center tube that we slide down over the threaded rod. And we torque this in. Now all you do is slide the element down over, and team number one, that's these guys here, they're going to install one of these so we can all see it. Then what we do is slide the element down over here. And then we put a spider on the top, our threaded rod sticks through, and we torque that. That has become very popular in the U.S. because in some areas you must crush your filter element, put it in an EPA drum, and then send it in to be properly disposed of. In some areas, they put them in the garbage can, the big dumpsters, and of course they pay on that based upon how many times they empty that out. So here's what we're going to see this morning before it gets hot. Then we'll come back in and talk about what we saw outside, and then we'll talk about the product line in total, and we'll go through our book. Any questions?
Ed, can I ask you on disposal of the elements? I was asked a similar question, how do you actually dispose of elements? Is there a standard here that says you must do this in the containers you mentioned there? Is there an actual standard laid down?
It varies by city, by state. Some areas you must dispose of them in an EPA drum. In some areas, an EPA drum is a drum that you buy specially that can be buried underground.
Okay.
And so you have to crush the elements, and the cost of a drum to have them deliver it to you, fill it up, and then someone who is certified as a waste disposal, EPA certified, has to pick it up. Probably a drum will cost you $125 to $200 per drum, standard 55-gallon drum. So you can imagine a large element that has a center steel core that is crushed. You're not going to get too many of those in a drum, so it gets very expensive. In other areas of the country, you can just throw them in the large dumpsters. They must let them air out first. That's a local regulation. You have to let them air out, and then you can throw them in a dumpster. Other areas of the country, you can take them out of the filter vessel, throw them into the dumpster, and off to the dump they go.
Okay. What about the oil, the residual oil? Is there any residual oil as such?
There could be some, but in most cases with diesel fuel and jet fuel, if they let them air dry and they hold them up for a while, they'll drain back into the filter, or they'll set them, they'll have a big holding tank where they'll set them in and let them drain for a day or two.
Okay.
But again, some of the worst spots in the country, you just pull them out of the filter and throw them back into the dumpster. Okay, any questions on a two-stage vertical? That's what we're going to see this morning. When we come back, then we'll talk about horizontal, single stage, so forth. Okay.
Dirt holding. Because it's going from inside out. That's going to be dirt holding.
Dirt holding. On your standard pre-filter, we are going to flow outside in.
Okay.
And we'll see that outside. Coalescers by nature flow inside to out. That's why you'll notice the pleated paper cellulose is on the inside. On a pre-filter, which we're going to see this morning, and on these, we're going to flow outside in.
Right.
Okay, so these four guys here are going to do the coreless. 4 people here down through Shashi are going to put in a pre-filter. Nelson and the gentleman next to him, you're going to put in a thread base. And Okoshi-san and his team is going to help put in a coalescer and a Teflon separator. What is the precaution for a Teflon separator?
You can't touch it.
Never touch it. Why? Okay.
You can touch it if you wear gloves.
Oh, Peter,
Hydro-
you're getting ahead of me here. You're getting ahead of me here. There's oil on your hands, and when you touch a Teflon, the oil on your hands takes off the Teflon. And you just as well like take a 20-20 and punch holes in it with a screwdriver.
I don't think it takes off the Teflon. I think the Teflon stays on.
It
It
changes
changes
its
characteristics.
Yeah, wet it up.
Yeah, you have
Oil.
to then clean it with IPA to get rid of that oil, and then it's
It coats
back
the
again.
Teflon.
Very, very difficult to clean. Very difficult to clean. And that's why when you touch a Teflon separator, you always wear gloves. So for Okoshi and his team, we have gloves this morning.
Clean gloves.
Clean gloves.
Yeah.
Clean white gloves.
Can I have white, please?
Yes, that's what we have. Okay, any questions? Now, we need one person to turn to the maintenance section. Okay, let's all turn to the maintenance section. Okay? Mr. Toolman, would you bring that section with you? Because that tells us what our torque values are going to be as we put each element in to the vessel. Because as we put our spiders on and we put the nut on, we must torque to so many foot-pounds, and this tells us the various types of elements and what the torque values are. We should always torque twice, because the first time we torque, we want the gasket to start to get a good seal here. And as we deal with our longer elements, they will flex. So we'll torque it once, kind of bump around a little bit, and then we'll torque it a second time. When we did our API test, because our elements were so well constructed, we passed the 75 PSID destruction test, and we did that without a center tube. You'll notice our API elements have no center tube. We're the only folks in the industry who don't have a center tube or some type of material inside of the media to give it strength. And what we found here is we did this with a 44-inch long element, that it flexed, it moved around, and we torqued 3 times till we finally got our torque values to stay. So torquing is very important. Why would it be important to torque and make sure we have a good seal?
Because the elements like to be torqued.
Why is torque important?
Well, if you don't get the,
Right,
so
the
yeah,
weight
I
up, you'll be
Yeah,
you'll
you have a
be
leak.
bottom.
Remember, 500 gallons a minute is going through this vessel. And by doing that, that allowed us to qualify our element up to 1,000 gallons a minute in actual operation in the field. So now you think about, in a worst case scenario, at 1,000 gallons a minute at 3% water. It's a lot of water. Okay. Any questions? Leave everything here. If you want to grab a cup of coffee and take it with you, that's fine. And follow me out. We're going out by the engineering test lab. Okay, so we're going to torque it, then we're going to rattle it around a little bit, and then we're going to torque it again. Now we know that we've got everything down on there tight where it goes. Okay, let's leave that one in there. Okay, Okoshi-san, where is our pre-filter guys that are going to install pre-filter? Okay, this one is a pre-filter, silicone treated cellulose, 44 inches, double open end. Now, notice I'm grabbing it here. I'm not going to grab it here. I want to get in the habit of getting hold of your elements thus. Okay, now, what rule did I just violate? I touched the element and
out of the bag before you gave it to him?
I took the bag off before I gave it to you. Hand it to the person at the vessel with the bag on it. Okay. Who's got gloves on? Okay. Here we're going to put in a pre-filter. Let me check one thing first. We need a spider for the top. Okay? Notice the spider has our knife edge seal, fits, and then the rod comes through. You can pick any rod you want. Huh? Okay, get your help over here. Somebody says you need to slide the base over a little bit. Okay? Is that too long for the rod? Yeah. Well, what will happen is it'll clear okay.
Yeah, but it's a hollow here.
It's hollow up underneath.
Yeah, but it won't be over. Is that Mr.?
The rod isn't coming through to tighten it down. It's too
The
big.
rod isn't coming through. Okay. Let's do this then. Let's try this one.
Take the paper out. Oh, get the paper out.
We're
just testing it.
Okay, now, look at the bottom before you turn it over. The other end. Look at the top end. Look at the bag before you tip it over. There's your seal, so you want to grab those when you tip it over.
Can I get this gentleman just to move just a little bit?
Oh, I'm sorry. I didn't see.
Thank you.
It doesn't matter which end you put up. Okay, good idea. We're going to put part number on top. Good thinking. Good thinking. Okay, here's our spider. We have a seal.
I've got one here today.
Okay, but we need a washer and a nut. And this is where it really gets bugs you. If you drop the nut in the washer at the bottom, then somebody's got to go digging. You only need one washer. Okay, what is this we have? We have a double open-ended pre-filter. Okay, Mr. Coolman, what's our torque? 10 foot-pounds. 10 foot-pounds. If you want to just move over one, it doesn't matter. Okay. Now, what we do the tempo then? Huh? How we do the tempo bit? Well, that's all right. You'll be out of there in a minute. We'll get another group. Now, what we would prefer for a torque wrench is one with a gauge, so you can see exactly what you're doing. Okay, there we go. We click. Okay, let up a minute. Kind of rattle your element around by hand. Okay. And then let's torque it once more. Yeah, we're going to click it up. questions on that? Okay, how about you guys getting down? We'll let everybody get up and get a look and see where we are right now.
You want to get down there to find us, huh?
Come on, Shashi, Paul. Let's get up there. Come on, Paul. About it. Okay. Paper, because if we don't, then the next What's our torque rating?
5 foot-pounds.
Okay, very light. All of them up to now have been what? How many foot-pounds? 10 and 20.
The flat seal on that is 7 foot-pounds.
We have
9 pin.
We have 9? Yes, the 9 pins again. Okay, let's go ahead and put that one in. Now, is that going on a long rod or a short rod? Short rod. Oh, I'm sorry. That's okay. That's all right.
I'm not the best camera in the world, so.
Oh, but it works.
Oh, yeah.
Okay, you got your spider, and there's the seals. Take the black spider off one.
Hey, Bob, get closer. So unscrew it all the way. and the angle you have on the bolt is going to increase or decrease the number of inch-pounds that you use just on tightening the bolt, getting it to turn. So you got to hold it square with the bolt. And you only hold the head, not the rod extension. want to do is put in a core. This is competitors, and we'll talk about this when we get in. This is a facet, and they build it in sections, and they snap it together. Ours is a one-piece aluminum. So let's find a rod to put that on. That's got to be on top. Yeah, you'll need to use that on the next one.
Okay.
Is it too short now? This we use in the beefus because this is for an 8-inch diameter element. What we're using here is for 6-inch. Then we also have one for a 4-inch. Okay? You got a nut and a washer? No, we don't need a spider. All we're doing is putting the core in, and then the element's going to sit over it, then we need a spider. Okay, go ahead. We don't need the elements good. No, we need the elements. No. You got to put that in first. Now, the biggest thing we have to check is this sitting on the stool properly, so we're going to get a knife edge seal on our element. Okay? I'm going to have to check. There isn't a torque spec for 2. So that's something we need to have. We'll just say for now 10. As open as that is, all you want to do is hold it down into the stool. Right? Because we're going to slide our element over the top of it. No more, probably no more than the filter, 5 foot long.
Okay.
Too short?
I said for 10.
No, too low. Huh? Yeah. 5 would probably be more than enough. That's only a plastic spider on the inside of it. So,
Okay.
yeah. That's why we're going to cut ours to length and match the element. I just want to show you. 12 inches, and that's what that is. And then we're going to slide a coreless element over that. What you can do is grab your API coalescer that you already have and slide it over. It should show you how it works. And what they should do on their internet is they should list it as loop meters on it. Or at least give it the version start. Well, that's way too short. That's why we're going to do a metal center tube when the main lengths are only, we're not going to do. Oh, the API one. This is just for the toolkit for the that's just the center tube to hold your element. We'll pretend that we pull your API element up and set it over there. Look at it. Huh?
Okay, here's a double open in. Yes, okay, let me have that one while you have it out of there. We're going to take it in the room with us. Oh, get to that look. Get to that sliding on or not? In the real application, our coreless element will go on that center bit, and we designed it that way on purpose. Okay, okay, everybody come down for a minute. Let's review what we saw. Let's pull all the elements because we're going to take them in the room with us, and we'll talk about them in there. Okay, now, okay, guys, he's going to hand me this element. Am I okay?
No. But if it's used, then it's okay.
Okay, if it's a used one, it won't hurt. But a new one, we never touch. Now, if we think we can clean this, I can do this if I'm careful. Okay, that's okay. But I don't ever want to do this. Yes, you can clean them, and you can do things, but generally what will happen is they'll change the coalescers about 3 times, then they change the Teflon separators. Because most maintenance guys will not take care of them. They're always doing this, or somebody will hand it to them, they'll wrap them like this. So that's why we say always wear white gloves. If it's dented like that, do not put it in, because we don't know what happened to our Teflon. See our Teflon, there's a little light. So that could be like poking a hole with a screwdriver. Okay, what else do we have in there? Just the center. It's on the top. That's right. We'll leave those there. Okay. Any questions on what you saw? Now, if this was a pre-filter, all we would put in would be elements like this. Pleated paper, a pre-filter, FP pre-filter, looks very similar to a paper separator. So, if this were a pre-filter, all the spools would be the same height, and we would put in how many posts do we have? 9. Okay, so we would put 9 pre-filters in if this were a pre-filter. Now, the guys in the field say, what does a pre-filter do? Your pipeline and refinery maintenance guys say it takes out the rocks and the wrenches that up in the vessel. So its job is to get the rocks and the wrenches out. Now, as we go further down the stream and we get closer to the airport, the more important your pre-filter becomes, and we'll talk about that inside. We'll show you some examples. As we get close to the airport, we're not going to use a 25 micron. We may have a 10 micron, a 5 micron, or a 1 micron because we want to clean the jet fuel up. And the big thing is we want to protect our coalescers. This may only cost the guy at the airport terminal, this may only cost him $20. This may cost him $70 or $80. So what does he want to change out? 10 of these or 11 of these? Very easy to figure that math out. So this job is to protect the coalescers downstream. Okay, let's check something here. Did we have a good seal here? How can we tell? You can see the ring from the spider. Now, where we get in trouble is if our marks from our spider are like this. And you can see it after the element's been in there a while. You will see the difference rather than this. And you'll know. And how they'll see it is on the delta P gauge. If this element, normally they change this element every month. Now they're going 5 weeks, 6 weeks, and the delta P is not coming up. Then they know they have a problem with the seal. So what you can do, if they're seeing a problem with real extended life, is to pull the elements out and always check your seals, top and bottom, to make sure that our spider left a round imprint in the middle of the gasket seal. Okay? Okay, so we had double open-ended. We had single open-ended. What two seals did we have on the bottom? And a seal. So those are the two kinds that you'll see in the field. In many of your pre-filters, on your pre-filters, you will see double open-ended. Most of the time on coalescers, you'll see double open-ended. Except, as Peter brought out, on horizontal vessels, they will use a thread base because now we're trying to get this in the vessel and get it aligned. If you have a spool, that's going to be very difficult to do. Now, one of our sales advantages with these has been, if I put this in the horizontal vessel and then I torque it down, now when I slide these on, I know that I'm going to have a good seal in a horizontal vessel. Okay? But if I take this and I have a knife edge seal, it's going to be pretty tough to get them lined up. And this is where we're going to help them with our all aluminum unit. Okay? And we're not going to put ours together in sections. It's going to be a one piece. Questions that you had and looking at this vessel. Okay, number one, what kind of vessel is this? Vertical. Vertical. How many stages? Two stages. Because it had what elements? Pre-filters. Okay, if it's a pre-filter, it'll have all pre-filters. This one, as it was designed for our API test, had what elements? What kind of separator? Separator. Okay. Why don't we take, if somebody will grab these boxes, we'll take them in the room. And if you want to take about a 10-minute break and have a smoke, see that there? You go, well, you take them there and there. And you take a gauge and you run it and put it here. Okay.
that going to?
What are some of the rules that we learned this morning when doing an element changeout?
Handling.
Handling, yeah.
Okay, touching the element,
Yeah.
that's a no-no. And let's put up here in front, nice and big. Okay, what else we learned?
Ensure the Teflon is not dented.
Okay, no dents. No dents or tears in the filter media.
Seal to be concentric.
Okay, good seal.
About making sure that the seal's even on the end of it.
Yeah, good point. We went through a QA period where Jim Kelso, our operations manager, he about had a cow. He walked out in the plant one day. Some employee thought, boy, we could really put these seals on faster if I brought my hot melt gun from home. Well, you can imagine what happened to hot melt when it got hit by diesel fuel and jet fuel. Jet fuel is very caustic. Okay, so we want a good seal, top and bottom. We want to make sure we have good gaskets. What kind of gaskets did you see this morning?
Unit in.
Unit in. Most universal accepted in these applications. What else did we learn?
After the first
Torque.
torque, make sure
Torque.
that you rattle them around and then get a second torque.
We want to torque twice,
Yeah.
and then adjust element. Just give it a little shake, make sure it's on there. What else?
You have a proper tool for torquing.
Good idea. We didn't have the proper tool. Torque, okay, we want the proper. And when you go out in the field and you go in the field at the facilities, they will have, and a lot of them like a nice great big gauge so they can see it real clear. Okay, what's the one big thing we learned today?
Make sure you put the right package in the right
Pedestal.
Okay. We want to make sure we have the correct element for the seal. You can't put a thread base onto a stool. You have to use a thread base stool. Come on, guys. What's the last one we got to have?
I'm sure when you're talking up the rod.
Okay, good point. Proper torque procedures.
Yeah.
What was the other one? Always got to wear gloves. Always wear gloves.
clean glove.
Clean gloves. One of our best customers is Mobile Oil, that handles all the fuel going into Boston Logan Airport. If, in this case, we've just started and we're using a metal end cap, and this is probably only one or two applications I know. These are stamped steel, and then they're coated, and you will have rough edges. At the mobile terminal, if an employee cuts a hand or a finger changing out the element, his supervisor must immediately fill out a work-related accident form. Within 12 hours, it has to go to the facility general manager. The general manager, the safety manager, and the supervisor have to meet with the employee within 24, 48 hours and discuss what happened and how could that accident be avoided. And that was one of the things that helped us get the business, because these are all glass-filled nylon end caps. Just like we use on a lot of Racor parts, like the black drain valves. That's what this is, glass-filled nylon. The other thing is, we can take these like this, and we can go, and you will not dent the end cap. Now, if I take this one, and you pick this up, I didn't really want to destroy it, but once in a while we do this with competitors. If you really dent the end cap, what happens to your adhesive seal between the pleats and the end caps? Consider you're going to have a leak. The other thing is, if this is like this because it's been bent, what happens to our seal?
Won't seal.
You won't seal. Good point.
Not
Okay.
Not a 5-foot pound you screw.
Okay. So we do have an advantage. The other thing is that our API coalescers and our coreless elements have no steel center tube like this one. So therefore, it is totally incinerable and is crushable. Now, if we tried to crush this one, we might get it down to here, and then we put it in a 55-gallon drum. But if we take a coreless, you can get them down in here somewhere. In fact, what some of the guys do, a lot of the oil companies are really cutting back on funds. So what they do is they have a bandsaw, and they'll cut off the end caps, and they tear out the paper, and they throw the paper into the dumpster, and all the metal parts go into another drum, and they sell it for scrap. But you've got a guy working at the terminal that makes $20 an hour, $15 an hour. You're spending money. But if you're spending $100, $200, $250 on an EPA drum, and you can only get maybe a dozen or 18 of these in the drum, makes a lot of difference in your final cost. Okay? Any questions? What you saw this morning with the vessel. Vertical, two-stage filter separator. Because we're going to filter the fuel, and then we're going to separate the water.
Hey,
Okay.
When those vessels are actually manufactured,
Yes.
do you have a flushing program before you even put any pre-filters in to make sure all the swarf or whatever else
Yes.
is in there? You do.
What was the other thing you noticed on the inside of the vessel?
There was some coating of...
It was an epoxy coating, and that's industry standard. Now, we even epoxy coat our Beefus vessels, and a new one we're going to show you today. Some of our competitors oil them inside. Now, if you're running fuel that will have water, and if you're in an ocean atmosphere where you may have salt water, what's going to happen in the interface of your drain area in the bottom, if you have water or salt water, it's going to corrode.
Salt is going to corrode real bad.
Yeah. So what's going to happen is, because you didn't epoxy coat the vessel, you're actually going to be contributing to filtration problems downstream. So all of our vessels are epoxy coated inside, and you'll notice even the lids are epoxy coated. And then that way you don't have any rust inside of the vessel. In your large vessels, like you saw this morning for refinery, pipeline, terminal, airport use, that's right in the specs. The vessel must be epoxy coated per mil spec such and such, and if you'll look at your brochure, you will see that it says that. What did I do with my 3 packages? Shashi, did you grab those to take them with you?
No.
I got to keep
let him grab.
I got to keep my
Eye
eye
on this
you.
guy, right, absolutely.
Did you get all of them?
Yep.
Okay. Keep my eye on Shashi. Every time he comes here, he's picking up extra stuff. Okay, interior, epoxy coated to mil C 4556E. In the U.S., North America, that is an accepted standard for epoxy coating. If you look on your sheet here, it will tell you standard design features. Also, all of our vessels are ASME code Section 8, constructed, stamped, and certified. Also an international standard. So this lays it all out for you, for your people. Then on the back, on the front tells you your flow ratings. It will also tell you the required number of cartridges. If we had a pre-filter and we wanted 5,000 gallons a minute how many cartridges would it take?
26.
26. Okay, let's go at the back. How big would that vessel be? B would tell us our height. How tall would that vessel be? 114 inches, 2,896 millimeters. That means that baby's going to be about
10 foot tall.
almost 10 foot tall. So you're going to see a very big vessel. Okay, so this gives you all your dimensions. Main thing you want to know is what flow rate does your customer want, and what is the fluid. Now, let's go, everybody look at industrial filter separator. Do you have that sheet, the green sheet?
Yes.
Yeah.
Okay. When I first read this, I thought, man, this is going to be a little confusing. Look at your flow rates. You have a different flow rate for diesel fuel, kerosene, and gasoline. Why is that?
Viscosity.
Viscosity. When we first came out with our VVFS, now called RVFS, we had ratings up to 150 gallons a minute, but that was done with jet fuel and kerosene, which you must derate 50% for diesel fuel. And it got real confusing. So on all of our new brochures, we show different ratings for the most common fuels that we run into. And that's why we say weights and volumes are approximate. Consult factory for any unusual fluids that they may be filtering, because as we all know, different fluids have different viscosities, and that does different things to your elements and your flow rates and your filtration abilities.
These are all US gallons then, right?
Yes, but we also show liters.
Yeah, fine.
Okay, and we try to do that on all of our literature because we know you guys use those funny measuring things over there, and then people in the Orient do it differently. And so we always try and put gallons and liters and millimeters so that our literature is good internationally. And that's the proper way it should be done.
Yeah.
Okay?
On
Yes,
that
Paul.
note, on this maintenance sheet where we have foot-pounds of torque, we should possibly add newton meters in.
Okay, good point. Good point.
It does have a conversion chart.
Okay, but we ought to show it right next to it,
Yes.
just like we do here in gallons and liters. You're right.
Yeah, it was quite good on the maintenance one that it had that pounds and newton meters and so on.
Okay.
This table, you mean that it have a element inside the vessel already?
I'm sorry. No, elements are not included in the vessel. Okay, let me give you an example here. Get my book back together. Okay, go back to vessels. Pull this sheet out. Everybody got this one?
Yeah.
What we tried to do was, you're in front of the customer, and he says, I want to buy a Racor vertical filter separator, number 1, 25 gallons per minute for DF2. And the most common applications that we've had so far on these has been for diesel fuel. That's why we're saying our ratings are at DF2. Now, when you get into your new if you pull this one out, you will notice our chart right in the middle.
Where was that?
Where is that?
Right in the middle of this one here.
Yeah, well,
It gives you about 3 different ratings: Jet A avgas flow rates, and then diesel fuel flow rates. So if you go into a customer and he says, I want to use this at a little local airport, and I'm going to filter jet fuel or aviation gas, then you can tell him with a Reefus 1 we can do 50 gallons a minute. But in the afternoon, you go over to the marine fuel dock and he says, okay, I want to put a Reefus 1 in, and I want to filter diesel fuel into all of the commercial fishing boats and tugboats that come in, and I want to flow 75 gallons a minute. The Reefus 1 will do it, right?
No.
No.
It's right.
3. You got to go to a 3 because of the difference in viscosity. So that's why we list and made it very plain in our new brochure. The old brochure gave you 50, 100, and 150 gallons a minute because we had rated it for aviation fuel. So, and it caused us some concerns in the field. Okay, so you have plenty of charts that you can tell your customer what they want. Okay, let's go back up. Everybody got your yellow sheet? Let's go back up to this. Let's pretend that this is a Reefus 3. And the guy says, I'm going to run diesel fuel through here, and the maximum I need is 20 gallons a minute. Reefus 1 going to do it?
Yes.
Okay. He wants a differential pressure gauge. What's the part number?
FS123.
What's part number?
70259.
70259. What if he wants a air vent?
Brass manual air vent 71152-75.75.
Okay. Now, what if this application he's going to do aviation fuel or jet fuel?
7206075. Definite bottom.
Where are you?
Definite bottom stainless.
Okay, he wants stainless. See our qualifier down at the bottom?
Yep.
Stainless is recommended for aviation service. You should never use brass in aviation service. No brass drain valves. We know Parker makes a lot of brass products, but we don't use brass in this point. We use Parker stainless steel. And we started a program in Henrietta where we have brass and stainless steel ball valves in stock. So if you're outfitting it and you're going through and giving the customer the target pricing, here, this is all U.S. list and USWD, and we shortly will have a transfer price card for Parker overseas boats. Okay, so here's all the different options. The most popular options are your differential pressure gauge. In this case, it's a piston type, but in our case, what we've seen most often is what you see out here in the hall, which is an actual gauge. And those work real good because they measure the true differential across your element. So you know how clean or how dirty your element is. The other thing that's very popular is a sight glass. And in most cases, we've been using a brass or diesel fuel, but we also have it in stainless. And the other most popular is a manual drain valve. Personally, I would not sell a vessel without those 3 items. The customer can always get a ball valve to put on the bottom, but you must differential pressure gauge and a water sight glass. Now, if they're going to be in an area where they're doing a lot of change outs,
When you say sight, that's those round.
yes, the round
holes
that's on the
yeah.
vessels out here. The other thing that I would do if there's a lot of change outs, I would use the stainless auto air eliminator, even though it's $450 approximately. And I would also have the pressure relief valve. Because in the field, a lot of times people don't open the valve slowly. They just open the valve all the way and bam, here comes the fuel from the pipeline into the vessel, and literally you could have metal parts flying through the air. We have started to do a lot of work with Delta Airlines, and they were talking the other day. 1,200 gallons a minute coming into the airport in a pipeline this big around. A trained fuel man was in a hurry. So he just cranked the valve all the way open, and the vessel was down here about 100 yards. And they were inside of the fuels building, which is like, you see the war room on TV. It has great big TV screens of every tank in the terminal, whether it's filling, how full it is, and the status of every tank, whether they're drawing from that tank, whether they're filling the tank, how many gallons of product is in there. So they're in the war room in their fuels building, and they heard this pop. And there was a vessel bigger than this one that we worked on. The lid ended up like 300 yards over here, and they had 1,200 gallons of fuel flowing. Actually, the dummy who turned the valve hadn't got too far away, and he got back and turned the valve off. But now, not only do you have the damage to the vessel, now you have an EPA spill that's going to cost you many thousands of dollars to clean up. And in the case of Atlanta Airport, they pump 1.8 million gallons of jet fuel a day just to Delta Airlines. The other airlines use about 200,000 gallons of jet fuel a day. So they're pumping in the neighborhood of 2 million gallons a day through that airport. And that's why they have the war room where they're checking every tank, and they have fuel coming down the pipelines into the airport 24 hours a day. So that's why this is important in your specking. You have to know what is the maximum. If the guy says, well, normally we're only running 800 gallons a minute. That doesn't count. What is the maximum that you can run into? So spec your vessel to the maximum. Now, I have a sheet made up that I'll give you today before you leave. These are your contacts in Henrietta. Do not send a request for quote for vessels, hydrocarbon elements here. Send those requests to Henrietta, because all that happens if it comes in here, then we forward it to Henrietta. And then I'll give you a list of contacts. If you want help with getting a vessel quoted, then you send that to Larry Cole and Dennis Thompson, and I'll have those names for you today. And then fax them with as much information as you can get. Flow rates, what's the fluid, what are the temperature ranges, and other things like that. Then they'll tell you what vessel, and they'll equip it with the elements. Now, let's flip this over. Here's all the elements that go into the vessel. Now, the REFUS and the RHFS, Racor Horizontal Filter Separator, two flow rates, 25 and 50 gallons a minute. Now we flip our card over, and we go down the columns, and I'll tell you what elements are available and what elements you want to use. So, and I'll show you a couple examples today when we get into our PowerPoint presentation that are going to throw you some curves, and it sure did us, on philosophies of what element you should use for filtering different products. And we'll show those in a little while. Okay, so here's all your element options. You can sit right in front of the customer and say, okay, Mr. Customer, you want a REFUS 1, and you want a 10 micron coalescer. What's that part number?
OCP 1585.
OCP 15858. Whoop, I'm sorry.
I need to know your maximum flow.
Yeah, 15858. Now, remember, we said coalescers fly, flow, inside out. Okay? A standard coalescer is a CP. An OCP is an opposite flow coalescer. So what's going to happen is instead of inside out, we're going to flow outside in. And let me show you that. And we'll see if, when we get a chance, we'll go outside and we have a cutaway of Beefus sitting out there.
So OCP was what? Opposite coalescer.
Okay, so what we're going to do first, here's our center tube. Here's our knife edge seal. We're going to set, this is going to be our separator. Okay, we'll come back to that in a minute. Now, on the outside of our vessel, we have, and I'll get out of the way here in a second so you can all see. We have our knife edge seal. So we are going to use, as you can see, art is not one of my better subjects. Okay, so here we're going to use an OCP, and we're going to use a separator. So we're going to flow outside in. So we're going to flow through the OCP. Our construction is going to be the exact reverse of these coalescers you have in front of you.
Are you saying the sock is going to be on the inside then?
The
fiberglass?
The fiberglass will be on the inside. It's actually going to look like a pre-filter, and you're going to have the fiberglass on the inside.
Will it still have a sock on the inside?
No, it won't have a sock. Okay, so what we're going to do, we're going to flow outside to in. So that means we're going to coalesce our water, and then the water droplets are going to come down the sump. Now, our Teflon separator is hydrophobic, so our minute droplets are going to gather till they get big, and then they're going to drop. Okay? Now, that's a typical setup for aviation fuel. We're going to use a Teflon separator. In some cases, Delta Airlines, for instance, they prefer a paper separator rather than a Teflon separator. Again, silicone-treated cellulose paper. And they prefer a paper or a synthetic to a Teflon. And then what they do, how often do we change a Teflon with a coalescer? 3 to 1. Okay. 3 coalescers to 1 separator Teflon. If you use an SP to a coalescer, they'll go 1 to 1. Every time they change coalescers, they change the separators. Okay, now, why did we set the reefus up this way to use an opposite flow coalescer and the separator?
Because of the filters being over the top inserted?
Yeah, that's one reason. But to the guys in this room, today you show up and the guy wants to filter. He's got a tank full of fuel and it's just really cruddy, but not a lot of water. Is he going to want to use a pre-filter with a separator? Does he want to use a water-absorbing element? Or will he go the standard direction? He can do any of those things in the same vessel. He doesn't have to replumb because we're always coming in here and we're always going out here.
You said it was pretty cruddy, though.
Yeah, so if the fuel's pretty cruddy, he may not want to waste $70 or $80 coalescers. He can use a pleated paper pre-filter, something cheap, and clean his system up. Now the next guy, and we've had some requests on the Beefus from tank trucks that deliver hydraulic fluids, and they have to have certain cleanliness specs and water specs that are taken when they unload the tanker. So what they've done is used a Beefus and they've used a water-removing H2O absorbing 1 micron or a 5 micron element so that they filter out the dirt and they absorb the water. And they put one big element in. Okay? That's why all of the beefus are in and out the same way. Now, if this was a true coalescer, we would come in here and out there because we want to flow inside out. That means when your customer installs this and uses it this year as a trash filter, and next year he takes it over and puts it on his diesel fuel tank, then he'd have to replumb the whole unit. Here, you only plumb it up once, and then you can change elements any way you want. That's why it's a very versatile unit. Now, one of the things that we've done to this, go back to the front page. Now, you have, let's go back to our vessels section. And you have these 2 sheets. Amy printed these real quick so we could give them to you. We're in the process of sending them. See, this has the photos on the back? Okay, we're in the process of sending those to the printers, and then they'll look like the 3 new ones we did today. What we found out was at Racor, a lot of the beefus units were going into marine applications. And the first thing they wanted to know is, why don't you put a bulkhead mounting bracket on there? Because aboard ship or in our big yacht, we want to mount it to a bulkhead. We don't want it standing on legs. We got to get it over here out of the road, and we're going to mount it to a bulkhead. So if you go back to your front of your yellow page, you have to state whether you want a bulkhead mounting brackets or mounting legs. See the difference in your pictures on the back? Of that one flyer, it shows 2 different ones. One with legs and one with the bulkhead mounting brackets. Now, one of the things when I was in Henrietta a couple weeks ago, what we want to be able to do, we're going to make a little adjustment so that we can get that top bracket above the ASME plaque. Right now, there's no room we're coming in here, and this is 2 inch. So here's our vessel, and right about here is our plaque. Well, we can't get that bracket around there. So what they're going to do on these specific ones, they're going to move the ASME code plate. They're going to move that down so we get this bracket here, and then we'll have another bracket here. That way, the vessel's not going to sit in the boat and do this, because we all know what happens when that starts. So that's one of the minor adjustments. So 4 of those, you'll see a little change in those. Okay, any questions on this or the vessel brochures that I gave you?
I noticed on the vessel brochure there isn't a torque spec for the lid nuts, nor is there a tightening specification as to how they're supposed to be tightened, in what pattern.
There is, you know, you're right, we don't show it in the torque sheet, but I believe there is on the ASME plate, but I'll have to check that. That's a good point.
They'll show a torque amount,
yes.
But will they show the torque pattern? Because it shouldn't be in a ring either.
No, it should just like you're doing a tire. You should be torquing back and forth. And the thing is, you have to watch out in the field because most guys will come out with a big old air wrench, and they really start tightening them down. So I believe there's a torque spec, but you're right, it should be on there. And I'd have to look at a plate to see if it's on there. That's another good point. Okay, now let's go to the next thing. Let's go to elements section. elements should be about the second section in your book. Okay, you have a yellow sheet there, first of all, and that tells you what are the designators on the front of our element. And let's go through that real quick. I'm not going to do them all, but I just want to give you a real quick code on how to read them. Okay, if it's a pre-filter, filter pre, 44 inches long by 6, and then the next number tells you your micron. And right now we're doing a study to see if we want to change that system. The first 2 letters and 3 numbers will stay the same. But you'll notice on our new API and others, what we're doing is ACP, coalescer, 4463, 0.3 micron. And on our FW, 18601, 1 micron, 0.5 micron. In some cases, I still haven't figured this one out. I have a little cheat sheet that I use. So what it tells you on your yellow page is FP, CP is a coalescer, ST, what's an ST? Separator, what kind? Teflon. Okay, then we have an SP, that's a separator paper. Then we have SS, which is separator synthetic. Okay, so those are pretty much explains what our elements are, and you can tell in a hurry. Okay, let's find the sheet that says pre-filter.
In the element section or...
In the element section, there should be a separate page on pre-filter, a separate product sheet.
Is it on please media or is that the one?
We had some temporary people help us put these together. Okay, I'll get you one. Okay, now we can go back to our main brochure under literature, and let's find pleated media cartridges, pre-filters. Okay, first paragraph, what does it tell us that a pre-filter is? Somebody just real quick.
Sorry, where are you?
Pleated media cartridges, pre-filters, in your main book, right there, your main book. You got it right here. Okay, go to, what page? Right there. Pleated media cartridges, pre-filters. Fancy name for pre-filters. First paragraph, what's it tell us that a pre-filter does?
High flow filtration, the applications,
Okay,
avgas, jet fuel, diesel, gasoline, lube, and hydraulic oil.
okay. What else does it tell us?
Applications.
Applications that are available.
And a warning about severe operation.
Okay,
It states some construction facts about the paper, silicon treated media,
okay,
synthetic fibers.
okay. High-grade silicone-treated media, synthetic fibers, available most popular lengths, selected grades of filtration media. What did we say outside? What's the purpose of a pre-filtered pleated media?
Gravel and tools.
Rocks and wrenches, gravel and tools. That is the 80% applications of a pre-filter. That's normally the first filter that you'll find in any stream to clean up the basic crud that's in the fuel.
Just a point there, Ed. Looking at those pictures there, you've actually got a little handle to actually pull
Yes.
those out. Now, you haven't got them on those. Now, that would be quite helpful, wouldn't it? With the length of some of them.
These, they're working on that to put those on. This, you'll notice those also show our old end caps. Those are not our glass-filled nylon.
They were also spider caps, so you didn't.
Yes.
Yeah.
Okay. Now, one of the things that we've done, go right across the page here. You know, at Parker, we always want to, and Racor especially, we always want to sell value added. Pre-filters, in many cases, is a 15-cent ball game. Bassett will sell them to me for $15.25, and your price is $16. I have to change them out every 5 days anyhow. In Brazil, we found out at the airport terminal that they were changing pre-filters about every 4 weeks. Here in the U.S. at the airport, they change them maybe 3 times a year. Now, if they got their jet fuel from Venezuela, which they do in some cases, they were changing pre-filters every 4 or 5 days. That's how bad it is. So we went to the coreless element because we all know that the steel center core costs you money. So when we went to the HIF coreless elements, we made another change to our unit. And when Racor Parker first took over Banner Filters, we had to make a lot of additions to equipment to modernize it, to bring it up to date. So we bought a German Robofsky pleater, $250,000. But it gives us a lot of advantages that the competitors do not have. It's all computerized. The part number's in the computer. We put the correct media in the front of the pleater. We punch in the part number, punch go, and the guys can go do other things. And it's pumping out the correct depth of pleat, the correct number of pleats per pleat block, the whole works. One of the things it allows us to do is put in a W pleat. So we have a pleat, a short pleat, a long pleat. There's your W. What this does, it gives us about 30% more surface area. Okay, now, the most popular elements in the U.S. in the pipelines and terminals are 44 and 56 inch. What always happens, if my fingers are the pleats, you'll have pleat blocking. Pleat blocking, that's a term that we use here, meaning that these pleats are not open. They're like this because your element is this high. And because the pleats are so long, you will have pleat blocking. So here, we are forcing the pleats open so that we can use all of this surface area. We're the only ones in North America that can do this. So on our pre-filters and our HIF coreless, we can do that. All you have to do is request. This works great with all fluids: hydraulic, gasoline, diesel fuel, kerosene, jet fuel, aviation gas. We have these in, a good example was Equilon pipeline. Equilon, you know, you read the paper every day, there's a new conglomerate. Equilon is the new conglomerate between Shell, Texaco, and Aramco in the U.S. Now, in the last couple of months, they've renamed it again. It's now called Motiva, M-O-T-I-V-A. So this is how fast things are changing in the field. They had a pipeline that ran from West Texas into Houston that originally they pumped jet fuel from Houston out about 400 miles. For some reason, they lost the jet fuel contract, so they shut the pipeline down and came back about 2 years later and said, okay, now we need this pipeline to send diesel fuel from the refinery out in West Texas into Houston. So the first couple of months that they ran this pipeline, they were going through 700 or 800 44-inch pre-filters a month. A month. So we went to a show in West Texas. The guy from Equilon came by and we showed him this. He says, you're telling me you're going to give me 30% more surface area, which should give me 30% longer life and should lower my maintenance during change-out times. Yes. He put them in. His element usage dropped from about 700-800 a month to around 400 or 500 a month. So he was very pleased because downtime on a pipeline costs money. Every time they shut the pipeline down, they're losing millions of dollars a day. And on some of your big vessels in your terminals, when they do a complete change-out, they will be down for an entire day. And normally that's not an 8-hour day. The guys are there 10, 12 hours to get all the vessels changed. And as we'll see in the PowerPoint, that's the reason that they'll have multiple filter systems so they don't have to shut the entire terminal down. So what we found, if you're in a pre-filter sales battle, don't mess with standard pre-filters. Take them to the HIF coreless with W pleats. Now you're selling value, extended change-out intervals. You're going to get more money per element. And you're going to make your customer happier, and you're going to give better customer service. Question?
Right, thanks. With the W pleat, in general, pleated construction of it, especially in the hydraulic element, the effective filtration area will be in the bottom of the V, yeah?
Yes.
How does that affect the smaller pleat in its efficiency?
What we have done, due to the number of pleats that we're putting in there, and the sharp break of the pleat, it's not a rounded pleat, it's an actual V, in both cases on the short and on the top of the long, is that generally fuel will seek the least line of resistance, so that if you start plugging the bottom of the W, then it will start moving up to the pleats that are not plugged and are not being used. What you'll notice too, though, is your delta P on your gauge is going to start coming, and once they start plugging, it's going to go boom.
And that would be in effect at the top of the W,
Yes.
W plate, yeah?
Yeah.
And that would go severely.
Yes.
Okay.
And that's why I say these type of vessels and these flow rates should never be sold without a delta P gauge. It's just, it's the only way you can really measure what's going to happen. Okay.
Have you said pleat blocking? Can you
Pleat
explain
blocking.
that? Yeah, explain a little bit again. I mean,
Okay,
Yeah,
if we took this element,
okay.
and this doesn't have the W pleats, but if this were a 44-inch long element, you'd see that
Okay.
in some cases. Okay, so that's your pleat blocking. And when you get to a 56-inch element, here,
Yeah, okay.
you're going to have pleats that are going to do this, and they're going to want to do this. So by putting in your W pleats, it makes them do this. They can't
So they are
block
more
together.
rigid, more rigid.
Yes, you're going to give inner support to them, but you're going to force them open.
Because contaminants just can't get through them.
Yeah.
They're blocking.
Yeah, but does the number of pleats increase or is it the same?
You will, of your deep pleats, you will have slightly fewer
It will occupy more space, right?
because you're going to occupy more space with your small one in between.
Right.
Now, we also have cutaways of these that I will send you, and it makes a very good sales tool to go in and sit down in front of the customer.
Yeah.
Okay?
You see, what I don't understand is,
So they're concertinaed so tightly, you've got the contaminants can't get round when they're blocked.
get that, right?
Yeah.
and you get your that.
Uh-huh.
Well, isn't it the same as? Well, you are taking away elements here.
No, because on a longer element, if you had these, you would have some of that,
Okay.
especially on your tall elements.
Right.
Okay? I believe I have a small HIF,
But
or
you
not.
can only get so many pleats in the
Yes.
in that.
Yes, and we are going to lose some of the big ones here by putting this one in.
Yeah.
But what we're doing is we're getting more effective use of all of our pleats.
So less media, higher efficiency.
No, you're going to have approximately 30% more surface area, but you're going
Effective
to...
surface or physical surface?
I'm sorry?
Physical surface, effective surface.
Yes.
So
So you're going to...
keep it overlap all the time. It's small.
You're going to open up the element where you're going to use all the paper, not part of it. And when we ran a test the other day, a qualification test. When we cut the element apart, you could see down inside of the elements, here down, were white, meaning red iron oxide had not gotten down inside the pleats.
Right.
Because on this one, our competitors in the API coalescer run about 60, 65 pleats, and we're up at 90. But when you look at our dirt holding capacity versus theirs, and your life on the Delta P, theirs comes like this, and ours is going like that. It's a very dramatic difference. But you're right, you can get too many pleats in the element, and we found that out here on the 2020 element, where we've tried different pleats, let's say 40, and that was not enough. 60 was too many. So now, off the top of my head, whatever that number is, it may be 52 pleats plus or minus 2. And then we know that on the curve, we're going to get high efficiency, high water removal ability, and longer life. And that's what we want to do on any element, is to give our customer longer life and less cost on overall filtration cost.
Your efficiency is determined by the media. Your life and your pressure drop is determined by the number of pleats and the depth of the pleats. And my best experiences with air filtration, engineering case, you can have too many pleats, and what that does, it doesn't decrease the efficiency, it just creates a higher pressure drop because you have so many pleats packed so tightly. You're explaining that you can't get the air through.
Yes.
So same thing here.
Yep.
Actually, I mean, it's an interesting topic, this, because, I mean, from the hydraulic side, we have the standard length pleats.
Yes.
Now, I'm just wondering if one or two of our competitors, like Schroeder and so on, because they make a big play on dirt holding and efficiency, I'm wondering if they're actually using this W pleating. It may be something that we need to adopt on the hydraulic side.
To our knowledge, we're the only people in North America that have a pleater that can do this. And one of the other things that helped us is that this new Robovsky pleater, we can pleat multiple medias. And
So
if you look at this
Robovsky
one,
pleater.
you'll see in the pleats there are, this one has 2 different medias, and one of our other elements there is 3 different medias in there. So, and that's the beauty of this pleater. Okay, any questions on what a pre-filter does?
Sorry, may I just stop for a moment there?
Sure.
Sorry, you were just saying about the Robovsky, so I'm just linking it over to something that's on the other filters.
Yeah, the ones in Dewsbury are Robovskis, brand new Robovskis.
So they're capable of doing
well,
what
possibly.
Ed's yeah?
It may be a particular specification that Jim Kelso specified when he bought the pleats from Robovsky. But, I mean, as far as being up to date, those pleaters...
I'm thinking about the ones that maybe that we buy in effective, let's say for the multi-flow and the maxi-flow and so on. bearing in mind that they're bought-in elements, they probably don't have this. So if we could adopt that, it might give us more of a sales opportunity, added value for better efficiency.
But you're thinking of having them made in reduced ground.
That's right.
One of the
Yeah.
options.
So this
But
is
we've
what's
got those brand new pieces in
Right.
reduced.
It's a good topic. then.
We have one distributor that has sold over 3,000 of the HIF Corliss to Petro-Canada for their pipeline, Les Hall. And he uses about 3 different sizes. And he has on the books at all times an order for 100 of each. And he buys them 100 at a time in 2 or 3 sizes. But the folks at Petro-Can and Shell Canada love them. That's all they're using in their pipeline now. Okay, let's go to coalescer. Yes.
This direction flow is outside in, right?
Yes. Pre-filters normally 100% flow outside in. That's correct.
And so I found some one place in the Thailand. This is a Japanese brand.
Okay.
And so that is inside out. And
Okay.
so can division can make in this order.
Sure. All we have to do is just reverse the pleat block. In fact, we made a couple samples of pleated pre-filters, and Wally Stone, who is our engineer here and our media guru, he looked at it and he got a big smile on his face, and he said, when you guys seamed this, they took the pleat block this way instead of going this way. And so the wrong side of the media was out for an outside-in flow filter. So, yeah, it can be done. Okay, let's go to coalescers. Let me go down to a coalescer, a large pleated filtration surface area and thick, high-density coalescing glass media delivers superior dirt holding capacity, excellent coalescing ability, and gives you clean, dry fuel to the end user. Now, you all saw this picture, right? See the big water droplets? I was amazed the first time I saw this new design that our guys in Henrietta put together, how large the water droplets are. Now let's look at something. And why is that important that we have large water droplets?
The larger the droplet, faster it will fall down.
Okay, that's one point. Now, here's our coalescer. We're coming up, we're flowing out. We have nice big water droplets. Now over here, we have a small ST Teflon separator. Now, Shaughnessy's right. We're going to use just plain old physics. These are heavy, so they're going to drop to the bottom. Okay, now, its basic job is to get 98, 99% of the water out immediately and get it to the sump. Its other thing in here is to get the contaminants out down to 0.3 micron. Okay, now, what happens if our coalescer is letting little tiny water droplets in? Now where's the pressure?
It's going to be on the filter, on the Teflon filter.
Right. The pressure is going to be over here, and that's not what it's designed for. Now, we're at the airport, and we're flowing 1,200 gallons per minute. So that means we're shooting BBs at this. So you can think of the velocity. We're shooting bullets at that Teflon separator. And that's not what it's built to do. This is the prime stopper for the water and the dirt. So by having nice big droplets, we're using physics that they're all going to go there, collect in the sump, and we're going to drain them. But if we've got a fog in here of little droplets, then what's going to happen? What are we going to find downstream? We're going to find water downstream.
Because it's going to go right through the Teflon separator.
It's going to go right through the Teflon separator. So what you do is these two guys, they're a team. They have to work together. You can't take just this one and do a complete job. And this one, it'll never last by itself. So these two guys, they got to be a team. They got to work together. And if they don't, then you're not going to have clean, dry fuel. Now, what we found out with all of our guys in Henrietta being jet fuel people, what we found out was that we have requests in the field that we want a synthetic separator in some cases, or in some cases, we want an SP instead of Teflon. Teflon is expensive. In diesel fuel, in the reefus and the beefus and all those, we think that's a better combination rather than the Teflon. Then what we do is every change out, we change them both. And the reason for this is, what'd you do with my element? I bet he put it in his briefcase. You gonna take it home with you? Okay, so what we have now in diesel fuel is we have all of this surface area for the dirt, and then we have this for the dirt too. Both of these medias are silicone treated cellulose. So they both have the ability to shed water to a pretty good degree. But the worldwide accepted for jet fuel and aviation gas is that combination there.
Tell us more about the synthetic.
I'm sorry?
The synthetic media.
I'll pass it around. You will see that it's a similar screen, but it's not a Teflon spray, and you can do this and it won't hurt it.
Is that rayon?
You know, I'm not sure. I haven't had that much experience with them.
But it separates water?
Yes.
As well as Teflon?
It's hydrophobic, like the Teflon, and it does shed the water. Okay? Any question what a coalescer and separator do together? Always remember, they're a team. They cannot work alone. They have to have each other to do a good job.
In case of we sell to replace this competitor,
Yes.
how can we know about the specification like a flow rate and operating pressure? If the customer asks me about what is the flow rate for this element,
For our coalescer,
and so future on any kind of element.
okay, good question. And then let me answer this one, and let's take a break for a little bit. Okay, coalescer. One inch. This is where you find out how good people's coalescers are. The industry average is 2.7 GPM per inch. Anybody have a calculator? If I have a 44-inch coalescer, how many gallons can that flow?
120?
109, just under 119. 118.
190?
Yeah.
Okay, so that one element can flow 190 gallons per minute. Okay, now.
119.
It's 119.
119. Okay, let's say I want to build a housing and I want to flow 600 GPM. How many coalescers am I going to need?
5.
5.
Number 5.
Okay, and then normally in a 5 box, you would have 5 coalescers and 3 separators. Okay, so this is the key here.
This is the catalog or this information is inside the brochure? Can you find any?
No, we don't like to publish it, but now you know. The reason I say that is because people will play games with this. This is why in your API report, and if you look in the back of your book, you have a complete copy of our API test that we performed with that exact vessel you saw this morning. The industry average is 2.7, 2.6, 2.7 per lineal inch, and that tells you where you are. So anytime you would call Dennis or Larry and say, hey, I need to set up this vessel, they have to know how many gallons per minute and the viscosity of the fluid. Yes?
Well, Ed, I think what Paul is asking, if we are replacing a competitive
Vessel application, where do we sell? What's the industry? Where are we going? So let's take about 10, 15 minutes, have a good long smoke. Koshi-san, Paul. Yes, Paul. I'm sorry?
Monitor, yes, 1
And that's on it.